Okay, we are going to be doing derivatives of inverse trig functions. So we are going to review them a little bit. What is an inverse trig function? Well, that really helps if we know what it is. It's an angle. So this is an angle, theta. Well, I don't know how to solve that. But what I do is I rewrite it as a sine of what angle is equal to 1 over the square root of 2. We could rationalize that. And what will help you on the exam is if you draw your triangles right at the very beginning. This is 1, this is 1, this is square root of 2. What's the angle? 45. And the other triangle, the only ones they're going to ask you for values of are going to be these special triangles. That's the only ones we know. I don't know any of the other ones. So what's this angle here? This is half the hypotenuse, so it's 30. 60. Okay, so if you have that in front of you, the last class said that they found it a lot easier having it in front of them. And so what's the angle here? What's my theta equal to? 45 or pi over 4. Just be careful with your restrictions on your domain, because if we don't restrict our domain, we get too many answers. There's an infinite number of answers to this equation. So I just want the first quadrant. So if it's positive, it's easy. It's just the first quadrant. If my inverse trig is dealing with negative numbers, then I have to think. And sine and tangent are the same. You go to the fourth. Inverse cosine of negative numbers, you find the angle in the second. That's the tougher one. So this is theta, which means that the cosine of what angle is the square root of 3 over 2. Now that I have a triangle drawn behind me, square root of 3 over 2. 30 degrees, right? And if you don't understand, please stop me. Because if you don't, probably somebody else doesn't. Yes? Because an inverse trig function is an angle. Yes? It doesn't matter unless you're in the multiple choice. Or unless they say, you know, your answer has to be between 0 and pi. Then you better be in radians. And how do I remember 30 degrees as pi over 6? Well, I want to make 30 degrees pi over 3, because then I'd have the 3's. But I know that that's wrong. So that's how I remember it. I want to write down pi over 3. I go, nope, that's wrong. It's got to be pi over 6. So what's 60 degrees? Pi over 3. You guys, how do you change them? You take 30 degrees times pi over 180 degrees. That's why it's 1/6 pi over 6. So if you have problems changing them, that might help. I do it a lot slower in the other video. Okay, what about this one? This is equal to theta, which means that the tangent of what angle is equal to the square root of 3. Grant? What's the tangent of what angle tangent is equal to the square root of 3? Look at the triangle. 60, right? That's right. Or I want to make it pi over 6, but that would be wrong. So it's pi over 3. Now, if you have an inverse sine or inverse tangent and it's negative, if I say that the tangent of theta is equal to negative square root of 3, then my angle is going to be a negative angle. So it's easy to memorize. So theta is equal to minus pi over 3. You can figure it out. You always find the reference angle, and then you have to figure out what quadrant. So if this is a negative number in here, my angle will be negative.
Wait, what's
Unless it's cosine. Tangent of theta equals negative square root of 3. The square root of 3 over 1. Shh. Pardon? No. We can only have one answer. So if I allowed it to be in the second quadrant, I'd have 2 answers. That's correct, but we restrict the domain because I don't want to have more than one answer. If you put it on your calculator, how many answers will you get? No, 1. Because your calculator is a function machine. It's a function. Okay, what about the next one? Inverse cosine of the cosine of 0.6. Right, you should be doing these. not watching. We haven't done those. Well, you could. What's going to inverse cosine and cosine going to do to each other? They don't always cancel out, but you just make sure that your angle is between 0. Now, for theta on this one, has to be between 0 and pi. It's 0.6 between 0 and pi. And I checked it on my calculator. Now, on the old AP exams, when they first started allowing calculators, they did crazy things where you actually had to figure out what quadrant it is and work backwards. And it would take me 15 minutes to do one multiple choice problem because you were given a calculator. Well, they changed that, thank goodness. They don't do that anymore. That was not good. Okay, ready? Now, I would like to find the relationship between inverse cosine and inverse secant. We're skipping the page on the derivatives of the inverses of functions until Monday, okay? You guys ready? Now, we know that the cosine of theta is 1 over the secant of theta. I'm tempted to say that the inverse cosine of x, then, is 1 over the inverse secant of x. I'm tempted. And we'll show you that it's not the same. No, it's on there. You have to skip a page because we're going to do that Monday. Because that stuff's kind of hard. This is bad enough. Okay. So, I'm going to start off with my inverse cosine. Inverse cosine of x, well, that's just an angle, right? Theta. Which that means that the cosine of theta is equal to x. Let me take my triangle and let's draw that, because I would like to find the secant of my angle then. So here's theta. If the cosine is x, then this is x here, and this is, oh no, it's adjacent over hypotenuse, right? What's this side? 1 minus x squared by Pythagorean theorem. I don't really care, but now looking at this picture, no, if the cosine of my angle is, if the cosine of the angle is x, and that's x over 1, then what's the secant of my angle? Look at this picture. It's 1 over x. Now, I'm going to solve, I know theta is equal to inverse cosine of x here. Let's solve this equation for theta. Theta is equal to inverse secant of 1 over x. Aren't the angles, didn't I stay in the same triangle? Aren't the angles still the same? Are the angles still the same? Yes, I use the same triangle to do the problem. Yes. Because this is cosine of theta is equal to x. What's that as a fraction? It's x over 1. Okay, so then what's secant of theta? 1 over x. Solve for theta. My angle here is inverse secant of 1 over x. My angle here is inverse cosine of x. Since the angles are the same, what has to be true? Don't freeze that. We don't have time for it. Okay, since the angles are the same, then these are what? Equal. So that's the relationship. Now, do I memorize that or even think about it? No, not really. Here's what you get. Slide this down. Inverse cosine of x is equal to the inverse secant of 1 over x. It's not the secant that's reciprocal, it's the ratios of the sides. Now, it's nice to know that. It's nice to know that this is not true. But to do a problem, I could use this, or I could just do the problem. And I'm just going to do the problem. No, you don't have to know this. We just have to be able to do a problem. So what does this mean? Inverse secant of 2 equals theta means what? The secant of my angle is equal to 2. What is that as a fraction? 2 over 1. So let's draw the picture. I want to find the angle. The only ones you're going to know are 45, 45, 90, and 30, 60, 90.
Is this in our packet? Or are you
Yes, it is. It's on the third page. You have to skip the inverse piece. Okay. The secant's 2 over 1. Where does the 2 go? Hypotenuse. You know, I don't do that much with these either, so I have to stop and think a little bit. And this side's what? We recognize anytime a leg's half the hypotenuse, anytime a leg is half the hypotenuse, we're talking 30, 60, 90. What's this angle here? 60? Right? So what's theta? 60 degrees. So theta equals 60 degrees or pi over 3. I could have used this little theorem here. It says inverse secant. These are reciprocals, so this would be equal to the inverse cosine and the reciprocal of 2, which is 1/2, which says that the cosine of theta is 1/2. Is that true? Yeah. I don't have to know it, though. I just think it's kind of an interesting fact, because I'm really tempted to say that the inverse cosine and inverse secant are also reciprocals. Intuitively, it makes sense, but it's wrong. Okay. Let me think about it. Okay. Now, these identities I'm going to use to help, and I'm not necessarily going to use them, but I'm going to practice with these because I don't memorize these either. And I want to find the derivative of the inverse sine and the inverse cosine. And I do think there may be some problems with inverse secant and cotangent, but honestly, they're not on the exam. So don't worry about those. Okay. Whoops. I'll get the right one. Okay, this is what? So what I want to do, you had to find the secant squared of y on problem 5 out of 3.7. And I said, just leave it, it's fine. I haven't shown you how to do that yet. Now is when we're doing that. That's an angle, isn't it? I want the sine of my angle. So cosine, I'll put theta here, cosine of my angle, theta, is equal to x over 1. So let's go to my triangle and put that in. Here's my theta. So where's the x go? Adjacent leg, and this is the hypotenuse. Can I find the other leg? Pythagorean's theorem, right? 1 minus x squared. Now, can I find the sine of my angle? So what's my sine of my angle? Yeah, it's the opposite over the hypotenuse, square root of 1 minus x squared. Yeah, kind of weird looking, but they're called identities. We'll just do it for practice. We're not going to memorize these. No. Okay, so here's my angle. There's theta. So the sine of theta is equal to x. There's too much stuff to memorize, so we're going to have to know how to do things if we need to. The sine is x, so this is x, and this is 1. What's this side? Square root of 1 minus x squared. So what's the cosine of my angle? This side over the hypotenuse, square root of 1 minus x squared. Did that right? I hope so. Okay, secant of the inverse tangent. Here's my angle. There's theta. The tangent of theta is equal to x over 1. So if this is theta, my tangent is x over 1. So this is x, this is 1. This is different now. What's the hypotenuse? Square root of leg squared plus leg squared, right? 1 plus x squared. So what's the secant of my angle? Whoops. Secant of theta is this one over that one. So it's the square root of 1 plus x squared. I'll put it over 1 so we see that. So when you did the secant squared of y, it might have been something like this. Right. How do you find the hypotenuse? It's leg squared plus leg squared and square root of. Okay, one more. So this is my angle. That means the I call it theta, secant of theta is equal to x over 1. Okay, so secant's x over 1. What's the hypotenuse? X. And this leg that's adjacent is 1. And now be careful, what's this going to be? It's not 1 minus x squared. X squared minus 1. Good job. And then I want the tangent of my angle. So the tangent is the opposite leg over the adjacent leg. They're all identities. I don't memorize them, I just work them out. So we ready? Now we have all the groundwork placed so that we can do this. Give myself some space. You know what? I'm just going to get rid of the secant. Probably in the homework, but these are the ones you need to know in the inverse cosine. And I'll tell you what that is. Okay, so here's what we're going to do. And why am I going through that? I could just tell you what the derivatives are. I could do that, but I want to make this y. I want to call this y, because you know what? We want to find the derivative. We want to find dy dx. But the nice part about this, or the part that's interesting, is why do we do implicit differentiation? Because I don't know how to find the derivative of the inverse sine. So let's rewrite it implicitly. This is explicit. Y equals that. Well, this means that the sine of y is equal to x. So now the y function is inside of another function, so it's not explicitly stated. But we can still do the problem. Let's do the derivative. That's why we did implicit differentiation. Yes? This is an angle. If you want me to call it theta, I can, but then I want the theta dx. I thought you'd be more comfortable with dy dx. Correct? So the derivative operator says I want to take the derivative of this side, and I want to take the derivative of this side, just like a square root operator. Square root both sides. Well, what's the derivative of the sine of y? In this part, I think you have. I'm not sure we can do it. I'm not sure we totally understand it. So the derivative of the outside function is the cosine of that angle times the derivative of the inside function. Do you want to call it y prime or do you want to call it dy dx? Okay, in the other class we call it y prime, so you have a choice. And what's the derivative of x with respect to x? So solving for dy dx, dy dx is 1 over the cosine of y. But here's the deal. I don't want to see a y in my answer. Divide by cosine y. Okay, so I don't want to see a cosine of y. So what is y? Slide these way down. Y was what? Inverse sine. So what it's asking me to do is this. It's 1 over inverse sine. Thank you. It's the cosine of inverse sine of x. And there's those identities, but I could go back and look because we did it, but let's just do it again. It's not that hard. So I'm going to draw the picture, right? So this means that the sine of my angle is equal to x. So I'll draw my little triangle. Here's my angle. The sine's equal to x. So this is x. This is 1. This is the square root of 1 minus x squared. Now I'm going to take the cosine of this angle. No, cosine is the square root of 1 minus x squared over 1. And the cosine's in the numerator or denominator? Denominator. So this is 1 over the square root of 1 minus x squared.
Wait, why did you say sine of theta equals x?
Because this is my inverse sine. Inverse sine is an angle. I could have just gone 1 over the cosine of y.
But why did you change from the beginning?
Just so you could see why we did all those goofy identities. This is the cosine of the inverse sine, which is right here. We did it. Because remember, this is y. We called this y. So I'm just substituting y back in there. I only want x's. Only want x's. Well, let's do the tangent, Ryan. But this isn't the cosine of the inverse cosine. That's when they cancel out. When these are inverse, these are not inverses of each other. If I had cosine of inverse cosine, then I would just get x. Yeah. Yes. Now we're going to do the same thing with the tangent.
Oh. Okay.
Okay, let's do the inverse tangent.
Wait, what cosine be? Should one cosine
Whoa.
be 1 minus x squared as 1 minus x squared over 1? Yeah. Why did you do hypotenuse over?
The cosine is, cosine of my angle is square root of 1 minus x squared over 1. But where is the cosine located? It's in the denominator. It's not in the numerator. Okay, we ready to do tangent?
Yep, you're good.
What's the derivative of tangent? Secant squared. That's the problem 5. Okay, so what we're going to do is rewrite this as y. So that means y is an angle. The tangent of my angle is equal to x. Because I know how to do this implicitly. I want the derivative with respect to x. And you told me that the derivative of tangent is secant squared of y. Then you have to chain it times the derivative of the inside function, which is what? dy dx. The derivative of y with respect to x. And that's equal to the derivative of x with respect to x is 1. Solving for dy dx, there are a couple ways you can do this. It's 1 over secant squared of y. Would you like me to change that to cosine? Because you don't like secant? Because what's 1 over the secant? It's the cosine. Cosine of y is equal to 1 over secant of y. Yes. So dy dx is equal to cosine of y, squared of y. Now, I could go and put y back in, because we know what y is, or I could just do this, because the tangent of y is equal to x. Right here. The tangent of my angle is equal to x. Here's y. This is x, and this is 1. What's that side? That's easier than the other one. Square root of leg squared plus leg squared. X squared plus 1, right? Yes. Because cosine of y is the same as 1 over the secant of y. It's just squared, that's all. And so I'm going to take the cosine of my angle. What's the cosine of this angle? 1 over that thing, and we're going to square it. So it's 1 over the square root of, and generally we write it this way, but it doesn't really matter. And we're going to do what? We're going to square this thing. Because 1 over the secant is equal to the cosine. We could do it this way, 1 over, and then what's the secant of my angle? It's just the hypotenuse. Square root of x squared plus 1 squared. So what is the derivative of the tangent? Let's simplify that. Inverse tangent, excuse me.
Are we going to simplify it to just 1 over 1
That's right. And you're going to see that a lot on the exam. You'll see that one.
supposed to have to relate that all that equals to the tangent, right?
That's right. These are 2 more you have to memorize. There's a third one that tangent of my angle is x over 1. And then I use Pythagorean's theorem to find the hypotenuse. Right. What do you think? Does anybody have an idea what the derivative of the inverse cosine is? It's the same as the sine, but it's negative. 1 minus x squared. Oh, I know it. Just look up, if you run into problems with secant or cotangent, just look them up. They'll be in the book, I think. You could look them up on Wolfram Alpha besides. Okay, so since we know this, that the derivative of the inverse sine, this was the derivative of inverse sine of x. This is the derivative of the inverse tangent. Let's do the chain rule. Yeah, favorite. What's the derivative of this composite function? Well, it's 1 over, I've kind of blocked out there, but it's the square root of 1 minus x squared. But what's my x now? It's not x. It's f of x. So this is f of x squared. And then what do you have to do? Times it by what? The derivative of the inside function, which is? Yeah, well, it's just f prime, right?
Wait.
Chain rule. First I do the derivative of the outside.
Oh, it's already used what we found.
Mm-hmm. Right, well, and we're going to do some problems. I got problems on the next page. What about the chain rule for the inverse tangent? Okay, there it is. It's 1 over, it's right in front of me. It's 1 over 1 plus x. But what's my x? F of x. So it's, yes, it's f of x, and it's what? Squared times the derivative of the inside function, which is f prime of x.
So that's all we can see in the end.
So it's just a couple more derivatives. And I have to look at the book, but the beginning problems should be just, practice taking derivatives. But the later problems might be applying them. Those are the ones, don't skip. We have 2 days on this. And it should be enough. Half hour each day. I wish we had time in class to do working problems and not send anything home with you. Unfortunately, it doesn't work that way. Chain rule. Derivative of the outside times the derivative of the inside. Yeah, I gave you that sheet. Remember, whatever's in here stays in there. Let's do a problem. Let's do these.
Oh, wait. We're skipping these.
What's these?
There's this.
Yeah, I took out the secants. You can look it up. I do know what they are. But, you can figure it out. Okay, what about this? Now, remember that the derivative, derivative of the inverse sine of x is 1 over the square root of 1 minus x squared. So this is 1 over the square root of 1 minus, but what's x? It's not x. It's x squared. And what are you going to do with it? Squared. Times the derivative of the inside function. Right. Also, when you do your homework, just because you can't do problem 1 doesn't mean you can't do problem 5.
Wait,
Yeah.
it's just like,
X to the 4th? Yeah, sure. If it's free response, I wouldn't. I would just write it in. Okay, so what's this one going to be? Square root of 1 minus. Now here's where I definitely don't want to square this. Times. You know the chain rule is going to be on the exam. That's all you need. Now, you will have to check your answers with my solutions that are online because the back of the book is probably simplified. I don't want you to waste your time simplifying. Although you should be able to do that. Now, do you remember that the derivative with respect to x of inverse tangent of x is 1 over 1 plus x squared? Second semester, we're going to reverse all this. I'm going to give you the derivatives, and you're going to find the function. And then we're going to apply it. Chapter 4 is all applications of derivatives. Chapter 5 is learning how to find antiderivatives. And 6 and 7 are applying those things. Things will come, when you get the application. So what's this going to be? 1 over 1 plus x squared. What's the x? It's the square root of x plus 1. Times, now I have to do the derivative of this, which is x plus 1 to the 1/2. I'm just showing my work. 1/2 x plus 1 to the what? Negative 1/2 times the derivative of the inside one, which is just 1. So just leave it. Leave it, leave it.
Wait, why is the 1 at the end?
Because it's the derivative of the inside function right here. Okay? And then a particle moves along the x-axis. Its position is the inverse tangent of the square root of t. How do you find the velocity? Take the derivative. I want to hit that so you guys get that. You're going to have velocity problems. Just take the derivative. Honestly, on the exam, you're either going to take the derivative or you're going to integrate. I mean, one of the two. Okay, so I'm going to do this. It's 1 over 1 plus the square root of t squared. That's just going to be 1 plus t, right? Times the derivative of the square root of t. Well, it's t to the 1/2. So it's what? 1/2 times t to the negative 1/2. And I have to evaluate it at 16. So I think I would like to simplify it before I put the 16 in there. And there are maybe some questions on that. Because this is t to the 1/2. What's the derivative of t to the 1/2? Because square root of t is t to the 1/2. So this is 1 over 1 plus t times 1 over 2. Now, t to the negative 1/2, the negative means it goes in the denominator. The 1/2 means it's the square root of t. Now we can evaluate this at t equals 16. If it's free response, I would just put the numbers in that line and leave it. Anyway, it's 1 over 1 plus 16. If it's multiple choice, you'd have to do this. 2 and the square root of 16. So I get 1/17 times 1/8. And I don't know what 17 times 8 is. I mean, I can figure it out. But that's it. Wait. How did I get that from here? 1/2. What's t to the negative 1/2? It's 1 over t to the positive 1/2, which is 1 over the square root of t. Do you want me to write it 1/2 times 1 over the square root of t? It's the same thing.
Well, yeah, but how do you get the 1?
How did I get the 1/2?
How'd you get the 1 over 1 plus 2 again?
Because that was the derivative of the inverse tangent. It's 1 over 1 plus whatever's in there squared.
Oh, yeah.
So on the next page, there is a little chart for you to fill in. Was there a question? Yeah. It was squared. No, there's no square root in the inverse tangent one. Nope, it's just 1 over 1 plus x squared. There it is. And then on the next page is a little chart. We'll get you a big chart. So you should fill that out. I'll give you back your quizzes.
Alrighty then.